the most interesting part, which is your application. Okay, application of resonance. And நம்ம பார்க்க போறது வந்து radio tuning. ரேடியோலாம் கேட்குறீங்களா? கேட்டிருப்பீங்களா? கார்ல போகும்போது நீங்க கேட்டிருப்பீங்களே. What all channels you know? 92.7,
91.5,
93.5, 98.3. எனக்கு தெரியும் 92.7 big FM.
yes,
93 என்னது? This is Suryana.
yes,
What is 98? Mirchiya?
Mirchi.
Radio Mirchi. சரி. So, what is happening here? இதெல்லாம் ரேடியோ ஸ்டேஷன்ஸ்லாம் இருக்கு. இப்பெல்லாம் நீங்க கார்ல போடுறீங்க. I don't know if you have seen those radios, tuning radios. இந்த மாதிரி இருக்கும் ரேடியோ செட். இங்கெல்லாம் வந்து இங்க இருக்கும். Okay, and there will be a knob here which we can rotate, and this will have an antenna. Have you seen this kind of radios?
Yes, sir.
So in the இடத்துல tune பண்ணா there will be some needle here which will go. அது அங்க 92.7 போன உடனே டக்குன்னு அது பாட ஆரம்பிக்கும். இங்கெல்லாம் வரும். ஸோ என்ன ஆகுது இந்த இடத்துல? ஸோ what are these? What does this number indicate? What do you think? These are frequencies. Okay, so 92.7 frequency, 93.7 frequency. இதெல்லாமே வந்து frequency. Now you have this antenna here, right? Now this antenna. And frequency na இதெல்லாம் என்ன மாதிரி waves? Radio waves, or generally we say electromagnetic waves. Correct? Radio waves என்னது? Electromagnetic waves தானே. ஸோ என்ன ஆகும்னா இது எல்லா ஃப்ரீக்வன்சியுமே வந்து இந்த சர்க்கியூட் இந்த ஆண்டனால will capture. So you'll have all these frequencies. Whatever frequency is there, it will all be there. Okay. Then what is there inside your radio? Adina, you have an LCR circuit. Okay. So you'll have a something like a resistance, have like a capacitor, and then you have like an inductor. Okay. So இந்த மாதிரி ஒரு LCR circuit இருக்கும் ரேடியோக்குள்ள, and இந்த ஆண்டனால, let's say your antenna. So all these frequencies are captured here. When now, due to your mutual induction, what we have studied EMI chapter, the frequencies will get in the it will be there inside your thing. Now, what is going to happen is, let's say that your 92.7 is your resonant frequency. Okay. Now, if you want to listen to this, basically you are going to set 92.7 as your resonant frequency. Okay. அப்ப நீங்க என்ன பண்றீங்கன்னா இந்த இடத்துல வந்து you are tuning this. அப்ப you are basically changing your முக்காவாசி இதுல வந்து you will only change the capacitor value, or some இதுல வந்து you can also change LNC value, and you are going to change your LNC value in such a way that your LCR circuit is going to have a frequency of 1/2 pi root of LC. Now this is 92.7. Correct? It will be 1/2 pi root of LC. Your LN values you are going to change such that you are going to hit this frequency. Once you hit this frequency, appa enna agum? Resonance la enna? What did we see in resonance? What happens to the current?
Maximum.
You will have your maximum current in your radio. So appada vandu, when you have the maximum current, you have your maximum power. When you have the maximum power, you will have your maximum current flowing through your speakers and everything, and you will be able to listen to whatever is playing in 92.7. Clear?
Sir, illana adu vandu it will still make a noise then.
Adu varuvom. Anyway, that is my have led me to the next topic. But principle wise, are you clear?
Yes.
Okay. So similarly, what they do in radio station, they are going to send electromagnetic waves. And this is what is your next chapter. Electromagnetic waves எப்படி produce ஆகுது? Because of you have an LC circuit. You have something known as an LC oscillation அப்படின்ற ஒரு topic இருக்கு, which is deleted, but I'll just give an overview of that. So you will have a circuit where you will have a inductor and a capacitor, and capacitor la can we store energy in capacitor?
Yes.
In what form?
Electric field.
In electric field. Can we store energy in inductor? Last chapter படிச்சோம் EMI.
Yes.
என்னவா?
Magnetic field.
Magnetic field. So you will have something known as LC oscillations. So basically ஒரு circuitல you will have a capacitor and you will have an inductor. அப்ப இதுல வந்து you will have energy stored in electric field, you will have energy stored in magnetic field. And this electric field and magnetic field or energy will keep oscillating. அப்படி oscillate ஆகும்போது you produce electromagnetic wave. So இந்த energy, இந்த L and C value வச்சு you can produce electromagnetic wave of some frequency. Let's say this is 92.7. அப்ப radio stationல they have a circuit, right? Oscillator circuit to produce a frequency, right? And they pass the data in that frequency. And the waves la வந்து the data, whatever is your, whatever they are speaking, right? They all get converted into electrical pulses. இதுவாகி they get transmitted. Then on your receiver end, in your radio, you will have a LCR circuit. அப்ப வெறும் LCR circuit ஓட you're going to change your knob in such a way that you will hit that frequency and you will get it. And not only radio, I mean earlier days, இப்பெல்லாம் இல்லை, முன்னாடிலாம் டிவியே வந்து மேலே ஆண்டனா இருக்கும். இந்த மாதிரி நீங்க பார்த்துருக்க மாட்டீங்க, பட் மூவிஸ்லாம் பார்த்துருக்கலாம். இந்த மாதிரி ஏதாவது பார்த்துருக்கீங்களா? வீட்டு மாடியில் சில பாட்டுலலாம் வரும், வீட்டு மாடியில் இந்த மாதிரி ஆண்டனா இருக்கும்.
Yes.
So anybody seen that?
Yes.
They will go and adjust the antenna. Some movies you might have seen. நாங்கெல்லாம் இருக்கும்போது when we were kids, அப்போ we had only that, ஒரு black and white TV. அதில் வந்து ஒரு knob இருக்கும். There are only 2 stations. ஒன்று வந்து மெட்ராஸ், அப்புறம் யூஸ் டு கெட் சம் கொடைக்கானல், அது ஒரு ஸ்டேஷன் ஒன்று வரும். தட் வில் பி ஒன்லி ஃபார் half an hour or 1 hour in the evening. So we need to go and tune it. அப்போ again the same principle. This all will get electromagnetic wave radiation. You have a circuit, LCR circuit, and when it hits that frequency, you will get maximum power to that or maximum current inside that circuit, so that and the data வந்து this will be, or that song will be played here. Clear?
Sir, அப்ப வந்து ஒரே சர்க்யூட்டுக்கு வந்து it can have multiple resonance frequency.
Yes.
Okay.
You change L and C, you can hit any frequency.
அப்ப it can be resonant at any frequency.
Yeah. So இப்ப என்ன ஆகும்னா, so let's draw this again graph, come back to that graph again. Okay. So let's look at I0 versus frequency. Okay. So இங்க வந்து I had my 92.7. So big FM. Okay. So this is my resonant frequency. அப்ப my graph is something like this, correct? Okay. அப்ப we can say that here I have my I0 maximum.
Yes.
I have a maximum current. I'm listening to this. But இங்க பாத்தீங்கன்னா 92.8மே பவர் கொடுக்குமா? 92.8 என்ன? இங்க பக்கத்துல வேல்யூ, right? So tomorrow you decide 92.7 வந்து நான் வந்து இது பண்ண போறேன். So I'm going to form another radio channel 92.8. யாராவது people வந்து 92.7 வந்து தப்பா 92.8 பண்ணிட்டா என்னோட சேனல் கேட்கணும் அப்படின்னு கேட்டா they will not allow you to have that value. Okay, there are certain rules where they will only allow, they will need to give some gap. அப்ப next வந்து எங்க வரும்? 93.5 இங்க வரும், somewhere here, correct? இப்ப 93.5 க்கும் you will have a similar graph. You have a similar graph.
Yeah.
And then அடுத்து என்ன பார்த்தோம்? 98.3 மிர்ச்சி, அதுவும் போட்டுருவோம். So next வந்து I have 98.3. So this also will have a, so as long as whenever you are tuning, up 92.7 வந்துச்சுன்னா you get your maximum. இப்போ வந்துலாம் பாத்தீங்கன்னா வச்சுக்கோங்களேன், so all your digital thing carல எல்லாம் வந்து it directly goes to 92.7. But if you have this kind of old tuning radio, you can hear some information probably till this value, which is I0 by root 2. The I0 by root 2 value வரைக்கும் you will be still be able to do it. 92.8 லையுமே கேட்கும். But என்னன்னா, it will also have some surrounding static. The static noise இருக்கு இல்லையா? It will not be very clear because you are not getting a maximum current to your output, which is your speaker. உங்க ஸ்பீக்கருக்கு maximum current போகல. அதனால you are also picking up other noises. But when you hit this current frequency exactly, you get the maximum current. அப்ப you will get a very clear voice. Is this clear?
Yes.
So if you look at this, இந்த இடத்துல, so this here, so this kind of overlaps, correct? Right? So which means that you still can look at information, or you can still receive information in these things, but you will not have enough power in your current will be very, very low. You will not have enough current to listen to your speakers. If you are really into kind of spying and all those things, anga வந்து என்ன பண்ணுவாங்கன்னா, they will try to have a circuit designed where it can pick up from very, very low frequencies, or low, when I say low frequencies na enna, இந்த மாதிரி where it is overlapping. அங்கேயுமே வந்து if I'm able to get, then which means that I don't need to pay you anything. Let's say that I need to pay for listening to your content and you are putting me in some frequency, 93.5 frequency ல வந்தா pay பண்ணாதான் கேட்க முடியும்னு சொல்றேன்னு வச்சுக்கோ. But 92.7 is free. But there is some overlapping here. If I have a good receptor circuit, right, I can still be able to pick at this frequency. Clear?
Yes.
That is how earlier days the radio எல்லாம் வந்து when they are passing communication, right, from in the war movies எல்லாம் பார்க்கலாம். So when somebody is communicating about where their tanks are going to be, அங்க spy வந்து they will try to intercept that information. எப்படின்னா, by listening to this very low currently may வந்து able to listen to that data. Clear?
Yes.
So this is
the waves length, can you tell எவ்வளவு பேர் வந்து are using the waves அப்படினா?
எத்தனை பேர் சர்க்யூட் பண்றாங்க இப்பெல்லாம்? lot of things are done. I mean, these are all we are talking about the old school, so analog இதுல. இப்பெல்லாம் digital. Okay, whatever we are just telling you, I'm telling you is still outdated. If you are going to go and study now electronics and communication எல்லாம் வந்து it will be all latest digital circuits.
Okay.
So carல எல்லாம் இப்ப நீங்க பண்றீங்கன்னா என்ன பண்ணுவீங்க? You just say scan and it will automatically scan and set to that frequency, right? You are not going to manually tune it. But even though it might give you a manual mode, but it can automatically tune, right? And car மேல antennas இருக்கும், பாத்திருக்கீங்களா? Right? So earlier சில கார்ல எல்லாம் வந்து it will be like a so some cars it will be like a big thing. இப்பெல்லாம் என்ன வந்திருக்கு? What do you know what is that called? இப்பெல்லாம் எப்படி இருக்கும் ஆண்டனா?
ஒரு ஸ்மால்,
இதுக்கு பேர் என்ன சொல்லுவாங்க தெரியுமா? This looks like a fin of a whale, சொல்லலாமா? Or a fish, or a fin. What is that fin? The shark fin la சொல்றீங்கல்ல? So these are now fin types antenna. You don't need to have like this big. இதுலயே now they are trying to receive maximum frequencies. Okay.
Yes.
Right. So now this is the principle. So we are saying that at some resonant frequency, my current is maximum, power is maximum. So which means that at that power and that current, I will be able to listen to it. So this is the concept of tuning of radio. But again here we can see that it is going to get, I can get data from from other frequencies as well. So can I say that in the range of frequency la எனக்கு 92.7% பண்ண முடியுமா? Right?
Yes.
This range I can still listen. So let's say this is 92.3. This is 93.2. அப்ப in the range வரைக்கும் I can still listen to this, right? So how do I reduce this? Or should I be concerned about reducing this or பரவாயில்லை உள்ளாமா? Which is a good circuit. I should reduce it, which is known as my sharpness of resonance. Okay, or we call it as bandwidth. Okay, bandwidth or Q factor, quality factor. So அப்போ வந்து ஒரு நல்ல டியூனிங்கா இருக்கணும்னா I need to have a very sharp resonance, right? Small bandwidth. I shouldn't have this much big, where I can listen the data from 92.3 to 93.2. இவ்வளோ ஒமேகாக்கு என்னால் இருக்கக்கூடாது. I should have these peaks this bandwidth very less. Okay, so we have some terms for this. So let's say this is my omega, and this is what it is. Okay, and this is my omega naught, and here is where I have my I naught max. Okay, இப்போ let's say I take these two. This is omega 1, this is omega 2. Appa this I call it as delta omega, right?
Yes.
So this delta omega, right, is known as the bandwidth, or basically I can say W2 minus W1. அப்ப எனக்கு வந்து sharpness இருக்கணும்னா my bandwidth has to be less, correct?
Yes.
For sharp resonance, my delta omega should be less, right? So what does it mean? Appa, if you look at this way, I know that in this case omega naught is my resonant frequency.
Yes.
Okay. Resonant frequency la I will get P max, and then I will have my I naught max, correct? Now what is P max? Did we see that it is I naught squared R by 2? Patama. Right? Now எனக்கு வந்து I want to listen to this, let's say till my current is I naught by root 2. What is I naught by root 2? IRMS. IRMS current வர வரைக்கும் எனக்கு வந்து I should be able to listen to that. IRMS க்கு கீழே போச்சுன்னா I don't want to listen to that station அப்படின்னு சொல்றேன். Okay, அப்ப what should be the power in which I should achieve that IRMS அப்படின்னு பார்த்தா, then can I write here instead of I naught by I naught, can I write it as I naught by root 2 whole squared R by 2?
Yes.
அப்ப இது என்ன ஆகும்? So this will become I naught square by 2 by 2, I naught squared by 4 R வருமா? So can I write this as P max by 2, because P max is I naught squared by R. Up I naught squared by R, I naught squared R by 2. This is I naught squared R by 4. So this is half of P max.
Yes.
Right? Up when my current is maximum, I will have my maximum power. And at my RMS current, I will have half of maximum current. Clear?
Yes.
Up this W1 and W2 another. So we call this W1, omega 1 and omega 2 as half power frequencies. Clear?
Yes.
At my resonant frequency, I will have full power. I will have full current. But I want to listen to my radio at RMS current itself. எனக்கு peak currentல இருக்கணும்ன்றது அவசியம் இல்லை. எனக்கு RMS currentல இருந்தாலே போதும். அப்ப RMS currentல இருக்கணும்னா I need to have it as I0 by root 2. அப்ப I0 by root 2 currentக்கு there are two frequencies. Right? And I0 by root 2 current எப்ப achieve ஆகுதுன்னா when I have half of the maximum power. Therefore, I can say omega 1, omega 2 as half power frequencies. Clear?
Yes.
So we say that this is the frequency where power is half of its maximum value. Clear?
Yes.
Okay. Even in this power, we say that even in this power, the tuning is audible, but it is not the best quality. Okay. Therefore, what do I want for sharper resonance? For sharper resonance, I need to have my delta omega, right, to be very less. Yeah. So what can I do here? So we say that this delta omega is R by L. From calculations, we are not worried about the derivation. Okay. The delta omega R by L irunduchuna, I will have a sharpness resonance. So what does it mean? If delta omega, right, this distance is R by L, can I say that omega 1 should be equal to omega naught minus R by 2L and omega 2 is equal to omega naught plus R by 2L? Does it make sense?
Yes.
So this is omega naught. I have omega 1. I have omega 2. This is delta omega. Delta omega is R by L. Upper, the whole thing is R by L. The whole thing is R by L. Upper half of it will be R by 2L. Correct?
Yes.
This is R by 2L. This is R by 2L. Upper omega 1 and omega naught minus R by 2L. Omega 2 is omega naught plus R by 2L. Prida?
Yes.
Okay. So we say that then delta omega is equal to R by L. Na? Upper resonance sharp arc na enna R should be small and L should be large for small delta omega. Delta omega is directly proportional to R, inversely proportional to L. Upper delta omega small, my resistance should be small and L should be large. Okay. So this is based on the sharpness based on bandwidth. So this is known as bandwidth based bunny. There is also another thing known as Q factor or quality factor. So Q factor is given by resonant frequency by bandwidth. So what is resonant frequency? Omega naught. What is bandwidth? Delta omega. For resonant frequency, can I write it as 1 by root of LC? Patama?
Yes.
And bandwidth is R by L. Q is equal to, can I write it as 1 by R or L by R into 1 by root of LC? Can I write it as root L divided by R root LC? Right? This will become 1 by R root of L by C. Solama.
Okay.
Root of LC கூட I can write it as root L root of C ஒரு L cancel out ஆயிடும். So this will be 1 by R root of LC. This is known as your Q factor. So this also is another way to set your frequency in such a way that your sharpness is more. So which means that you will have your delta omega will be less. ஒரே நிமிஷம். For sharpness or better tuning, delta omega கம்மியா இருக்கணுமா? Q ஜாஸ்தியா இருக்கணுமா?
Yes.
R கம்மியா இருக்கணுமா? C கம்மியா இருக்கணுமா? L ஜாஸ்தியா இருக்கணும். So these are all the requirements.